mentioned, okay, today, okay, so that you will keep in mind, okay, for the rest of the semester. So what you learn for chapter 3, okay, will be used throughout the rest of the syllabus, okay, especially on the calculation of mean, standard deviation, okay, whereby especially these two, okay, mean and standard deviation, and also variance, will be used throughout, okay, the rest of the syllabus. So if we were to be in face-to-face lecture, okay, so usually you need to rely on your scientific calculator to perform this calculation, okay, but because of the nature of our online learning. So if you look at your OL, okay, I already linked few, I think in your OL, okay, you can see I already uploaded few additional materials, okay, especially on the website links to how to calculate, these online tools to calculate your mean, standard deviation. Okay, so you can find that in your OL, which I uploaded yesterday. Okay, this one. First, how to calculate mean, mode, median using Excel. So this is a YouTube video. Okay, and then these two, okay, statistics calculator 1 and 2. Okay, so we'll be using this one, okay, to perform some of the basic calculations in your, this can also calculate mean, mode, and median. Okay, 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 so for the calculator, okay, we have this mean, median, and mode, okay, for the calculation of our the things that we need to calculate for chapter 3, okay. So we go back to the syllabus, to the slides, okay. So in chapter 3, we have, if you look at the list of things that we need to learn, okay, throughout chapter 3, okay, explain the concept of central tendency, okay, and then identify and compute mean, determine the median, identify the mode, okay, explain and apply measure of dispersion, and number 6, okay, compute and explain variance and standard deviation. So this is what I mentioned just now. And lastly, these two theorems, Chebyshev theorem and also empirical rule. Okay, so this last theorem, okay, again, okay, it will not just be applied in topic number 3 alone, okay, but also for the rest of the syllabus. So you need to understand why you we learn these two theorems, okay, because in statistics and also in economics, whenever you collect data, okay, so especially on the empirical rule, okay, whenever you want to perform a hypothesis testing, okay, so the argument that you justify whether you want to reject or you want to accept your hypothesis, okay, will be partly or mainly based on this empirical rule as well. Okay, so for today's lecture, okay, we're gonna cover on item 1 until 4, okay, concept of central tendency, mean, median, and mode. Okay, so we're gonna cover these first 4 components. Okay, and then on the following class this week, okay, we're gonna cover on this measure of dispersion. Okay, because once you understand the concept of central tendency, then we're gonna proceed to the second part, the measure of dispersion. Okay, and also finish up on this empirical rule. Okay, so I don't expect to spend more than 2 weeks, okay, to do this. Okay, the most we're gonna do is for 3 classes, okay, this week and perhaps next Monday. Okay, so we're gonna see how you all participate during the class. Okay, so what I need to do from this week onwards, okay, because we're gonna rely on the ebook, the main textbook exercises. So that's what I usually do whenever we have a face-to-face lecture. We're gonna do exercises from the online book directly, okay, not just using. So the slide is just for the beginning, and then we're gonna do as many questions as possible from the book, so that, and then again, because this is a online session, so how do I know whether you are doing the exercise during our lecture? So I will just call upon your name at random, okay? And if you are doing it on your computer, okay, because most of the stuff you can just do it online, because I already give you the link on the scientific calculator, the link, this one, okay, where you can calculate the mean, the mode, okay, so you can just plug in the data here, and you can just click calculate, and you get directly the answer. So, but I just want to make sure that you are on your laptop, okay, learning this, okay, so not just on your phone, lying down on your bed, okay, and not maybe just online, but not really focusing. So so from this week onwards, okay, this is how we're gonna do our lectures. Okay, so you need to be alert, okay, and also keep in mind, okay, we are going to use our ebook a lot, okay, from this week onwards. So let me start with the concept of central tendency. Okay, so the word central tendency, central means center, in the middle. Okay, so basically when you have data, okay, so we want to know the characteristics of our data. Okay, so the first part is central tendency, and the second part, as discussed just now, the measure of dispersion. Okay, how dispersed is our data? Okay, so this one we cover next class. Okay, but for today we're going to focus on central tendency. So the word central tendency is how the tendency of your data to be concentrated in the middle of your data. Okay, so there are three common approach, okay, to analyze the location of your data, whether it is, how your data is located, or where your data is located, okay, what number or which number or what value that is located in the middle of your distribution. Okay, so let's say you have 100 numbers. Okay, so you want to know which number is in the middle of your distribution. If you sort from lowest to the highest, okay, from smallest to the highest value. So the word central tendency is basically pointing at data in the middle of your distribution. Okay, so we have three main ways. Okay, the mean or the average in simple term. Okay, we call it average. Okay, median. Okay, the number in the middle, and mode, okay, the number with the highest frequency. So I'm sure you have heard or you learned these three components or concept before. So that's why I think this chapter is still quite easy. Okay, maybe the only difference is the use of your calculator or the formula. Okay, especially on the standard deviation. But for the mean or average or prorata, there shouldn't be any much problem. Okay, so arithmetic mean or mean is the most widely used measure of location. So in chapter 1, okay, we already analyzed there are 4 types of data: nominal, ordinal, interval, and ratio. So interval and ratio, more or less, we can group into into the same category. So interval means, okay, you can take the value from 0 until infinity. Okay, so so the number can be arranged, okay, from lowest to highest. Okay, the difference between each of the observation, you can interpret the difference between the first number and also the second number. Okay, so the characteristic first, all values are used. So when you want to calculate the mean or the average, if you have 10 numbers, you need to use all 10. So unique mean, there's only one value. Okay, so that is what unique means. Okay, only one value of mean for one observation. Okay, and the sum of deviation from the mean is 0. So this one I will show later from the slide. Okay, what it means by the sum of deviation from the mean always equal to 0. Okay, so the formula is basically you add everything and divide the number of values. So if you have 10 numbers, you add all 10 numbers, you total it up and then divide by 10. Okay, so I think the word average or mean, okay, is very close to our day-to-day life. Okay, meaning you apply this thing, this concept whether you realize or not. Okay, so the same thing as your CGPA, your pointer, is basically on the mean. Okay, it's divided by the total grades that you get for the semester and divide by the number of credit hours that you take. So that is basically the mean of your pointer. Your CGPA is basically using the mean concept as well. Okay, so in statistics, okay, the difference between when you learn statistics and just simple mathematics is that in statistics you need to know the symbol or the notations that represent the concept that you are looking at. Okay, so in statistics, okay, so you need to know the difference between population versus sample. This is what we discussed in our first week of lecture. Okay, what is sample and what is population? Okay, population is the whole item. Okay, you from A to Z. Sample is just part of the population. Okay, so if your UM students, the whole of UM student is considered a population. Okay, a sample means maybe you just take a few hundred students. Okay, some student from economic, some student from other schools, from business, from accounting, from IT, from law degree. Okay, so let's say you want to take 300 students to ask a simple questionnaire. So that 300 from the whole of 25,000 plus UM students, okay, will be the sample. So that 25,000 is the population. Okay, so in statistics, whenever you get your data, so you must know whether your data is referring to the population or does it refer to the sample? Because in terms of calculation, okay, for the mean value, whether it's population or sample, the formula remains the same, but the notation is different. So we start with population first. So you will see throughout the syllabus from chapter 3 until chapter 10. Okay, so the syllabus will be divided according to two parts usually. The first is we're going to cover on the population. Okay, what if the data belongs to a population? What is the formula and what is the symbol that we use? And then what if your data belongs to the sample? What is the symbol and what will be the formula? Sometimes the formula will change if you are using sample. Sometimes the formula does not change. Okay, only the symbol that change. Okay, so here for population mean, the symbol is mu. Okay, this u we don't call it u lah, we call it mu or mu lah. Okay, so summation, this symbol I think you should know by now is the sum of. So x is the number of units. I mean the number of observations. Okay, referring to the value. Okay, n is the number of observation. So summation x over n. So you notice that this n is capital N. Okay, because you are referring to the population value. Okay, if I skip, let's say we go to this slide first before we go back to the previous two slides. Okay, so we started with the population mean and then we continue with the sample mean. So if you compare with sample mean and population mean, sample means instead of using mu, we are using x bar. Okay, so x bar is the notation for mean, but when the data belongs to the sample. And summation x remains the same, but n now is the small n instead of capital N. Okay, so from x bar, if you're using x bar, meaning that the mean is referring to the sample. If you're using mu, the mean is belongs to, you are referring to data that represent the whole population. Although the answer remains the same, okay, when you punch your calculator or when you use online tools or even in Excel, okay, or whatever software that you use, the value remains the same, whether you are using data from sample or from population. Okay, but in terms of writing, when you want to prepare a report, okay, when you are writing your paper or your thesis, okay, okay, so the notation changes that which represent your data. here we have a simple data set. Okay, so and then we're gonna calculate what is the why is this information a population. So that is the first question. Okay, so why is this population not sample? So because the statement just mentioned in this case, okay, of course, since this book is from the US, so the example is all US based example. Okay, so there are 42 exits, meaning it's just like our highway. Okay, so let's say from the north to the south. Okay, how many exits from the total exits from the north to south? So this is the number of exits. Okay, that from on this stretch of this place in Kentucky. Okay, so according to this, okay, so this should be the population data that represent the whole exits. Okay, in the highway. Okay, so you want to calculate the population mean. So basically what you need to do is just you add every item from the first until the last one. So summation X is adding all. So N is the number of how many items is there in the data. So there are 42 observations. So 192 divided by 42, you get 4.57. Okay, I think this is this is not this is not something new to you, although you are learning this under the syllabus of BEEQ1023. Okay, but that does not mean that this formula or the way to calculate this is you only see this thing for the first time. Okay, I'm sure you have used this formula many times before. Okay, so just take note on the symbol. Mu represents population mean. Okay, so then we're gonna cover on the sample mean, which is the formula is the same, but the data belongs to the sample. Okay, just like the example I used just now. If there are 25 students, 25,000 students in UM, but you only select, let's say, 300 students to do a simple survey. Okay, it can be any topic. Let's say you want to take 300 students. Okay, you construct a simple Google survey form or using SurveyMonkey or whatever online tools. So that 300 students will represent the sample. Okay, so if you want to take, let's say, the mean of some observation, some information that you get, okay, so the mean should be summation X over N as well, but the N should be small n and mu is replaced with X bar. Okay, so the same thing here. Okay, so you will see that throughout your book, okay, and whether in the slides or the exercises in our ebook from the Lin, our main textbook, Lin et al. Okay, so you will see that whenever the books refers to sample, okay, it will mention. You will see the word sample mentioned in the statement. A random sample of 12 clients. Okay, the first word is random. Random means rawak. Okay, meaning that the sample is taken at random, meaning there is no preference, there is no particular choice. Okay, it can be from anyone. So that is what the word random. Okay, but the most important part is the word sample. So whenever you see a statement clearly identify this data belongs to the sample, so the rest of the calculation, whether you are calculating the mean, you are calculating the standard deviation, or if we proceed to the future topics, to chapter number 7, 8, 9. Okay, so the word sample means that the technique used need to take into account that the data belongs to the sample. Okay, because there is a difference between if your data is sample versus population in terms of the sample, in terms of the way you conduct the tests. Okay, so that need to be considered as well. But in terms of mean, okay, the easy part is that only the symbol that change, okay, from mu to X bar, okay, but the calculation, the way you punch in your calculator or you use the online tool or you use Excel, okay, it still remains the same, summation X over N, okay, so you add everything, 90 until the last number and you divide by the number of items, which is 12, you get 97.5. Okay, so this is the first component or the measure of central tendency. Okay, so as what we discussed earlier just now, there are three components or three methods to calculate refers to central tendency. Okay, meaning your data is located somewhere in the middle. Okay, you want to analyze your data, so you want to know what is the number that is located somewhere in the middle of the observation. So the first is the mean, where you add everything, divide by the number of observation. The second will be the median. Okay, so the word median, I think, is not something new to many of you as well. Okay, the word median is data that is located somewhere in the middle as well. Okay, but it does not involve any summation. You don't add anything. You don't divide by anything. It's just you arrange from smallest to the largest. So I think when you are using Excel, okay, in Microsoft Excel, sorting from small to large, okay, or from smallest to the highest is something very common. So you can obtain that from using uh, Excel. Okay, I mean the concept of median is basically you need to arrange your data from the smallest to the largest, or vice versa, from largest to the smaller, because it will be the same thing, is the number in the middle. Okay, if you recall when you are in your kindergarten or in your primary school, okay, whenever your teacher asks you to line up, okay, outside the class to go to the padang, to go to the field, or to go to the canteen, okay. Usually when there is like, usually the teacher will arrange or will sort the student from the shortest to the tallest, okay, in the class. So the tallest will usually is the last person, okay. The smallest or the shortest student will be the one in front, okay. So midpoint, the median is basically the midpoint that you obtain by arranging your data according to the value from small to the highest, okay. So just like mean, okay, whenever you are looking for median, there should be only one value. One median value means you cannot have two median in one data set. Okay, so only one median. So that's why it is also a unique value. Okay, and this is the mean advantage. Whenever you are using mean, okay, if you go back to this slide here, okay, all values are used. Okay, of course it is not mentioned in the slide. Okay, but you can add in your own slide. Okay, another point in your slide is that it is that it is affected by extremely, okay, by extremely small or large value. Okay, so meaning that, let's say in your sample data, or let's say in your classroom, okay, you want to take the average of the weight of student. Okay, I will usually use this example in the class. Okay, so let's say there are 40 students, okay, in our class. Okay, of course, in our class there are more than 50 students. Okay, there are 40 students in one class, and you want to take the mean, okay, the mu of the weight, okay, in kilogram, okay, the weight in kilogram of the students in the class. So meaning that if you want to calculate the mean weight, okay, in kilogram, okay, what is the average weight of the students from student number 1 until the student number 40. So whenever you are calculating the mean, means that you need to add everything and divide by 40. Okay, but let's say in that particular class, okay, there is one student, okay, which the student's weight, let's say, is extremely big student. Let's say his weight is 200 kilogram. Okay, so maybe he used to play sumo in Japan. Okay, that his weight is very. Let's say he is a foreign student or exchange student that comes to UM only for one semester. So this 200 kilogram student, okay, will be added into the calculation uh, with the other 39 students, okay, in the class, which usually for Malaysian people, okay, people are students around the age of 20 to 23. Okay, on average, okay, if for female students, it can be from, let's say, okay, 45 kilogram to maybe 55 kilogram or 60 kilogram. Okay, but for male, it could be more than around 70 kg to 80 kg, depending on your height, okay, and your age, okay, but not 200 kilograms to kg for sure, okay. But when you want to calculate the mean, this student will be added as well, and your mean value will be brought up, okay, will be increased because of this one student. Okay, it's the same thing as your pointer. Whenever you want to calculate your CGPA for one semester, if you get all subjects, let's say A minus or A, suddenly one subject you get F, you get a fail for that subject. So your CGPA will be brought down by that one particular subject. Okay, because it is an average. So that is what it means by affected by extremely small or large value. Okay, so this is the disadvantage of using mean. Okay, but if you are using median, okay, it is not affected because you don't add anything, you don't divide by anything. You just arrange from smallest to the largest, okay, and you get one value that is located in the middle of your data. Okay, so it can be computed from ratio or interval and also ordinal data. Ordinal means you can rank. If you recall, the ordinal is the second type of data. Okay, you can arrange according to the value. For example, puas hati, sangat tidak puas hati, or amat berpuas hati, or fair, good, okay, very good. So those kind of data ordinal. Okay, so you can arrange according to ranking. Okay, so so let's see how you can calculate median. So again, I'm sure you have done this before. So if you have a set of numbers, so you just arrange from smallest to the highest, and the number in the middle will represent your median. Okay, so for odd numbers data set, I think this is pretty straightforward because the number in the middle will is because if you have odd numbers, then it is clear, it is quite easy to determine what is the number in the center. Okay, but if your number of data is even numbers, okay, nombor genap, so you need to take the two middle numbers, you add and you divide by 2. Okay, so let's say here you have 73, 75, 76, and 80. So these two numbers represents the number in the middle. So to get the median, just add these two and divide by add these two and divide by 2 lah. 75 plus 76 divide by 2, you get 75.5. So the median is the number in the middle. For even numbers, you need to do a bit of simple average for of the two numbers in the middle. But for odd number observations, okay, like this one, there are 5 observations. So the third observation will be the one, will be the median value. Okay, so I think this is pretty straightforward for the median. So again, if you compare median versus sample versus mean, okay, median it is not affected because you don't add anything. So even though in the classroom there is one student that weighs 200 kilogram from Japan that used to play sumo, but that student will not be affecting the median value because, okay, so if you arrange the data, okay, from smallest to the highest, so the highest student the biggest student or the heaviest student is that 200 kg student, okay. So but the median will always be the number in the middle, meaning that even though the student is in the class, but your median is not affected by that 200 kg student. Okay, so that is what it means by not affected by extremely large or small values. Okay, so the same thing here, just using these simple numbers. So what we're gonna do later, okay, once I finish on this thing, we're gonna do a bit of exercise from the ebook, okay, using the online tool that I shared with you earlier, okay, and determine how to calculate the mean, mode, and median from that tools. Okay. So, and then this is another example. You have a sample of 10 adults. So again, the word sample means this is not from population. But for median, there is no difference whether it's sample or population because the formula is just basically arranging from smallest to highest. Okay. So here, since this is an even number observation, meaning the number is even, okay, bukan nombor genap. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 observations, meaning this is an even number observation. So the median will be the number in the fifth and the sixth. Okay, so nombor yang kelima dan nombor yang keenam, the fifth and the sixth observations. So you add these two, okay, and then you divide by 2, you get 6. So 6 is the median lah. Okay, so you only need to do this if your data set is even numbers. Okay, but let's say if I add one more number, let's say this one is 18. Okay, meaning I add another number. Now our observation is 11. There are 11. Our n is 11. Okay, there are 11 number of observations. So now you don't need to use this approach, because if your observation is 11, the median will be the number, the 1, 2, 3, 4, 5, 6. Okay, so this will be our median. Okay, because if you divide into 2, you're into half. So this is one half, this is another half. So 7 will be the number in the middle. Correct? Okay, yeah. So there are 5 observations here and another 5 observations if I add another number which is equals to 18. Okay, so for even numbers, you need to take the number in the middle and divide by 2. For odd, it's pretty straightforward. Okay, so it will be 7 for the median. Okay, and finally is the mode. Okay, mode I think is again there is no adding or division involved for median. For mode. Okay, meaning mode is the value that has the highest frequency. Meaning if what you learned last week, okay, when I asked you to submit a simple histogram, bar chart, okay, pie chart using Excel, okay, on the y-axis is the frequency value. So the one with the highest peak, okay, with the highest that appear the most, okay, so that will be the frequency, will be your mode value. Okay, so here just a simple example of a histogram. So the y-axis is the frequency, the number of responses. Okay, so the highest will be the mode. Okay, so of course, what you did last week, okay, for that short small assignment, okay, you can do that directly using Excel. Okay, and Excel also has the function. If you look at the video which I provided the link in your OL. Okay, so in eViews, if you highlight your data and you put the command mode, okay, mode MODE, and the eViews, Excel can detect automatically what is the number with the highest frequency. Okay, the same thing with any online tools, okay, that you can use. Okay, so basically mode is the highest frequency data. Okay, but unlike mode and median, because median just now there's only one value of median, okay, and also there should be only one value of mean, meaning you cannot have 2 means in one data, or you cannot have 2 median in the same data. But for mode, okay, you can have more than one mode in one data set, meaning that if there are 2 numbers that appear that has the same frequency value, so meaning that so here, let's say in this example, there's only your mode is clearly this one. But let's say we artificially increase this one to the same, meaning this observation and this data and also this data has the same number of frequency. So your mode becomes these 2, not only this one. Okay, so for mode, you can have more than one, not only, so it is not a unique value for mode. Okay, meaning you can have more than one mode in the same data set. Okay, as long as the frequency remains the same. But if like in this original example, the highest frequency is only this data, so only one mode. But if you have two variables that have the same frequency, the same highest frequency, then your mode can be 2, or it can be also be more than 2. So for using Excel, okay, you can refer to the video, okay, which I provided the link. Okay, so I'm going to finish on our lecture before we do a bit of exercise, okay, on the online tools that I provided just now. Okay, so once you understand the concept of mean, median, and mode, okay, So earlier in the beginning of our lecture, all of these three components, it is what we call the measure of central tendency. Okay, so you want to visualize if you want to do a research, okay, that based on numbers, okay, you have data collected from your survey, from any sources, okay, from websites, okay. So before you do any analysis, further analysis, you want to have a quick idea of what is my meaning, what is my mean, what is the average value, what is the number that has the highest frequency, the mode, or what is the number in the middle, which is the median. So so once you have those three values, okay, and you can plot them into and when you plot your data in a simple histogram as what you did last week, okay. So in statistics, okay, whenever you plot your data, okay, so the the way, I mean the shape of your histogram, okay, in statistics, you can interpret them into what we call as skewness, okay. Skewness mean it comes from the word skew, okay, whether it is skewed to the right or skewed to the left, or it is not skewed at all or in the middle. Okay, let's say if you drive a car, okay, of course this is not the exact meaning of skewed, okay, but if you own a car or you normally drive a car and your steering wheel, okay, your steering wheel, so if you are, I'm not sure for female, okay, but for male drivers, usually if your steering wheel is not in the center, let's say if you drive straight on the road, okay, if you drive straight but your steering does not point, it's not located in the middle, meaning it might be, let's say it might be a bit skewed to the right, meaning that you will see that the alignment is off. Okay, so you need to go to the alignment, the tire shop, and do the alignment of your wheels, so that when you are driving straight, okay, in a straight line, the steering wheel will be positioned at the very center, meaning the I mean if you point your steering wheel straight, okay, so the car should go straight, okay. But if you point the steering straight, but the car might be turning slightly to the left or to the right, so that is something what the word skew means lah. Okay, if your car is steering to the right, although you are pointing the steering straight, then then you can call it is not so the skewness is not zero. Okay, so something like that. But of course, in terms of data, okay, whenever we mention about skewness, is where does your three measure of location, mean, mode, and median, is located? Okay, is it located in is it located in sorry? Okay, is it located in the all of these three values are located in the middle, or it is not? Okay, so if every values of mean, mode, and median are all in the same point, or the same, that belongs to the same value, mean is 20, median 20, mode is also 20, meaning every component or every measures of your central tendency belongs to the same value. So we call that data as zero skewness or not skewed. Okay, so that is what zero skewness means. Okay, but if your mode is on the left, your mean on the right, median will always be in the middle, no matter whether zero skewness, positive or negative. Okay, the one that may change position is the mode and the mean. Okay, but median will always remain in the center. Okay, so that is again another unique value of median, because it is not affected by extremely small or extremely large, because you don't add anything, you just arrange from smallest to the highest. So whether it is positive skewness or negative skewness, median always in the center. Okay, so if your data is positively skewed, meaning if you look at this, okay, if you look at this data here, you have some extremely large value on your right. Okay, so if we plot like this, okay, so positive skewness that happens because there are some data on your right side that are extremely big. Okay, if you recall my example just now, there is one student in the class that weighs 200 kilogram. Okay, so if you add that this student in the calculation of the mean weight, okay, purata berat, mean weight of the student in the class, so you will have a positively skewed distribution. So when you plot your histogram, okay, when you plot your histogram based on the class interval, okay, as what you learned last week, okay. So here is your class interval, here is the frequency. Okay, but suddenly there is one or two students that is extremely big student in the class, so that will pull the tail of your distribution to the right. So that's why we call it positive skewness, meaning that the mean is located on the right, but the mode is located on the left. Median is always in the middle. Okay, but if your data is affected by extremely small value, okay, positive is extremely high value, extremely big or high value. So negative skewness is the opposite way, around. Okay, mode is on the right, mean is on the left. Why mean is on the left? Because the mean is the average. So why mean becomes smaller than mode? Because you have extremely small value. So if we reverse this example, okay, so let's say in the class there is one student who is extremely small, very tiny student. Let's say the weight of this student is 30 kilogram, very small. Maybe it is not logical example, but just to get the message across. Okay, so when you want to add the mean weight of the student in the class, there is one student who is very small student, maybe not a healthy student, okay, only weigh 30 kilogram. So when you add the mean of the student's weight in that classroom, okay, the entire classroom mean purata will be affected by this one student small weight. Okay, so the mean will be pulled to the left. Okay, so that's why in a negative skewness, the mean is on the left, the mode is on the right. Okay, so mode is bigger than median, is bigger than mean. So this one, the mode is smaller than the median, smaller than the mean. Okay, but as long as you understand this concept, positive skewness, it is affected by high positively or large value. Negative skewness, the data is affected by extremely small value. So the word negative is something on the left, positive is something that is affected on the right. Okay, so that is so basically when you plot your histogram last week, okay, on the exercise which I gave. So of course, I mean, if you I did not check on the exact shape whether okay, it can be a zero skewness, or it can be a positively skewed, or it can be a negatively skewed. Okay, so this one, okay, these two is the extreme or the okay, is two unique scenario lah, okay, affected by extremely large value. This is extremely small value. But if your data is just nice, meaning on the average, there is no extremely large, there is no extremely small value, there is no extremely large, there is no extremely small. So it's just a normal distribution. So in statistics, zero skewness is what we usually refer to as a normal distribution. So when you look at your syllabus from chapter 6 onwards, okay, you're going to look at the concept of normal distribution. Normal distribution is referring to a zero skewness distribution. Means that your mean, mode, and median is somewhere in the middle, meaning they are located in the same value. Okay, so a zero skewness is also can be called as a normal distribution. Okay, because the shape is normal. There's no strange or extremely small or extremely large value in your distribution. Okay, so that is what you can take from when you plot your data in a histogram. Okay, your y-axis is the frequency, your x-axis is the interval, class interval. Okay, so what you learned last week on chapter 2 is being directly applied here in the concept of skewness. Okay, so I hope you can understand this concept. So if you get confused, okay, whether it is positive or negative, okay, so if this is positive, where is the mean? Okay, so the mean, if you understand the concept of mean, you add everything. So positive skewness is extremely large value. So of course the mean will be pulled to the right. Okay. So negative skewness, the data has extremely small value. So the mean will be pulled to the left. So mean will always be on this side. Median tak berubah. It's always in the middle. Okay, so the only place that so you only swap places for these two, either mode or the mean. Okay, so that is the important part that you need to understand. Okay, on this concept of skewness. Okay, okay. Any question? Ada soalan? As usual, semua faham semua? Okay, let me open our ebook. Okay, on our. Okay, please open the link to your OL. The one that I opened just now on this one. SO SOX test, this one lah. SOX statistics, whatever the. Okay. You can refer to the chat. Okay. I put on your chat box there in your okay. So we're gonna apply this thing directly. Okay. Of course, I would prefer you to use your Casio calculator. At least try to use your because in your OL I also put the video link. Okay, how to use your calculator. I mean, I assume many of you are using Casio rather than Canon. Okay, if you are using any other model, then go and figure out okay how to use that calculator to calculate the mean and also variance and standard deviation. Okay, because if by next semester you can come to UUM already and you might have subjects that you will need to calculate this, use this method again to calculate mean or standard deviation. Okay, so you need to learn how to use your calculator. Of course, you cannot bring your laptop to the exam hall. Okay, so that's why you need to know both lah. But because of the nature of our teaching this semester, okay, so I need to think of ways lah, okay, how to um, how to do this okay, this exercise in the in our classroom. Okay, I mean in our Webex. Okay, so if you have your ebooks with you, okay, so what I need to, okay, so open your ebook on page, what page is this? Page 83, okay, or page in the actual page number, I believe will be page 80, yeah, 83 lah, okay, page 83, okay, in your OL, sorry, in your textbook, okay, muka surat 83, okay, question number 53. Okay lah, we do question number 54 first, okay. It has less observations, okay, but if you are okay, so question 54, okay, so open this one, okay, you have this one, the mean, median, and the mode, okay, calculator. Okay, so if you open on the link here, click on the descriptive stats. Okay, we have the mean, mode, and median. Okay, variance and standard deviation we're going to cover on the next class. So for today, we're going to use the mean, median, and the mode calculator. Okay, so here you have your if your data is nominal, ordinal, or interval ratio. So our data from question 54, okay. So this one is clearly an interval or ratio data, okay. So we're gonna use, most of our data will be in terms of interval or ratio. So you're gonna use this option instead, okay. So your data will be calculated. I mean, you need to key in your data from top to bottom, meaning 952. So you need to hit here 9 and then 5, 2, okay, and then continue to the value. So meaning one. So the data is only key in terms of column. Okay, there shouldn't be any number here. Okay, so 952, and then you continue 6, 5 until the last number 3. And then once you finish key in, you just click on calculate. You should be able to get your, all of these three numbers will appear. What is the mean? What is the median? What is the mode? Okay. So do that. Okay. I will leave it to you. So I will ask anyone at random based on the attendance. Okay. So I will give you 5 minutes to do it. Okay, so calculate the mean, median, and mode. Okay. Okay, make sure you choose this one, the mode, median, and mean. Use interval ratio. So just key in and then just simply, if I only have these three numbers, so it will just give me the mean as this one, median, and mode. Okay. The mode sometimes is not accurate. If you have too little numbers, then it might not be accurate. Okay, but the mean and the median should be fine. Okay, because if I only have 3 observation, okay, the mode it shows as 9, which is not correct. Okay, but here because 9 is the number with the highest value, that's why it detects as 9. Okay, but if you are having the same numbers based on frequency, so the mode will detect the number with the highest frequency values. Okay. Okay, T Chin Yi 279778. Can you share your screen briefly?
Yes, doctor.
Yes, since everyone is calculating online, so you can just simply share your screen whenever I call. Even though I will expect everyone should get the same answer, because what you do, you just key in and just press the button. Okay, you don't really actually calculate this thing manually, right? So, but I just want, again, everyone is in front of your laptop, okay, not doing something else. Okay, so okay, so the mean 4.84, okay, 4 and 4. So does everyone gets the same one as well?
Yes, doctor.
Yes, doctor.
Okay, Ainul Bashira, can you share your screen? 281733. Ainul Bashira. Okay, so this is a simple, straightforward application or tool that you can apply. Okay, so this will be, you can apply or use this one, okay, throughout the whole semester. Okay, whenever you want to calculate the mean, or okay, in our next class, okay, we're gonna use this to calculate variance and standard deviation. Okay, if you click on the link on the variance and standard deviation, you will see that there are two options, whether for it is using sample data or population data. Okay, so that one again also we will cover on next next this coming Thursday. Okay, so you can do the rest of the whatever number that you feel that you have from the book. Okay, again, your book has solutions to odd number questions. So anything that you see on the book on the chapter exercise, okay, okay, thank you, Ainul. Okay, so in your chapter exercise, anything that has if you're referring to odd number questions, okay, 51 chapter exercise, okay, as long as it is odd number, for example, question 51, okay, is odd number questions, so you can go to the answers at the back, okay, for chapter 3. Okay, so I believe you can get the solution as well here. Okay, somewhere in the solution for chapter 3. Okay, so just one question number 51. Okay, you should be able to get the question 51. Yeah, okay, the mean is 34.06, the median is 37.5. Okay, so you can do questions that has answers just to verify whether the one that you key in your data, I mean in the book, okay, using the calculator online, will have the same numbers or solutions, okay, as the one that you the one that you key in the book. Okay, so this is, I think, should be our goal for today lah. Okay, so please do check on the video on the using Excel. Okay, how to calculate the mode, the median, and the mean. Okay, using Microsoft Excel. Okay, so because I might give you another small project. Okay, just to make sure that everyone is actively engage, okay, in our class, okay, not just watching from your laptop or your phone, okay, and at the end of the day you don't really understand what is going on. Okay, because at the end of our chapter 3, as I mentioned earlier, you're going to have your first test. Okay, so the first test, will cover chapter 1 until chapter 3, okay, whereby you need to calculate the mode, the mean, the variance, the standard deviation, okay, using your calculator or using whatever link that I provided in your OL, okay. So that is the skill that you need to acquire, okay, for this coming, for this week, okay. So I think that's it for today, okay.